Welcome to a new test and teardown video. This time it's a power supply from Oltronix. This one is the type LS14BS. If you have been following my channel for a little while, you will most likely recognize this a little bit because I already released a video about a half a year ago of model 115, and that is a little bit different from this LS14. I should just put in a picture right here so you can see side by side the LS115 and this one, the LS14. So you will see the difference. We got more possibilities for the instrument switch. We got another extra output voltage, and we got current protection. This is not a current limiter, but I expect this one will be like a trip point, and then a relay will go clickety clackety. So I think this is not a constant current mode, because this is how it is normally implemented in Oltronix tube power supplies. We got individual DC on off on the outputs, and it is again 0 to 500, and we got the two different voltage ranges. That is of course a tapping of the transformer and all that kind of stuff. The case is the same, the meter is the same, those connectors here, they're also the same. We got a powerful filament supply, and we got a weak just a potentiometer voltage divider here, and then we got the new supply right here. There is a little problem with a bent connector like that, and you can see this is pretty much bent, but I have an idea about finding a metal tube that will stick on top of this, and then I can bend it back, hopefully without damaging anything. Since this one is a tube unit, and since we have bent parts, I definitely want to open this and do a careful inspect before I try and power it up. Let's see if this is going to work. Here's my metal, and then I'm gonna try and bend it careful. See? That went okay. What I did is I put some cardboard in here to create the right diameter, but I didn't put in a little paper on the top here, so I created a little dent. But anyway, it's now nice and straight. So that was not the dumbest idea. And then push it back. Funny idea. So let's have a little look inside. I am both happy and also a little bit sad that this one is so much different compared to the previous power supply I already released a video about, because that means I do not have a schematic, but I think the fundamental basis ideas about everything here is probably more or less the same, but it is just very, very different. First of all, we see only 3 EL34s, and that is for the main power supply. That will be the driver for that one. And we got a total of 15 tubes, where quite a lot of them are voltage regulator tubes. Look at that one, 85A2. We got OB2 and OBA. That's also an OB2, right? And then another 85A2. So yeah, that's a lot of voltage regulator tubes. There's a funny little circuit board here, also with a little tube. Oh, look at that, a transistor. a germanium NPN transistor. Isn't that fantastic? So maybe this one is driving the relay for current. It looks like a little bit misplaced, this circuit board, while everything else is in socket mounted in this bracket. So this is some sort of an upgrade, right? I was able to track down some date codes, and that is 1961 on most of the capacitors. So I now know that this unit is from 1961, and my guess was just 1960. So I'm quite happy to be that close for my guess. We got some selenium rectifier bridges. Here is another one. This is one of the big, hefty ones for high power. So I would expect this one is the main 500 milliamp output. I don't find any leaked capacitors, so there's nothing holding me back. I will now try and power this up. Oh yeah, look at what I did. I cleaned one of the tubes just to show you how big a thick layer of old dust there is on the tubes. The problem is that they of course all run really nice and warm, and with a thick layer of old dust like this, there is a really nasty smell coming out of this unit. So I definitely want to clean the tubes. I really recommend when you're cleaning tubes, don't clean the tube exactly where the label is. Let me take this out so you can see what I mean. Because you want to keep the name of the tube intact. Luckily, this was pointed down, so all the dirty was here on the top. Yeah, but I want to clean a little bit more here. And then I'll start my little power up. So now I'm ready to power this up. I think that'll be the two variable power supplies. That one is just the potentiometer output, and that is not super interesting. And yes, I have everything turned on. Also, mains is turned on. My variable input here, and then I'll just crank up. And then I will 100 watts. I don't see anything that is bad, so we just go on. It is using 250 watts at 140 volts. That is not so good. So, yeah, the reason why I have all the light here dimmed, that is because I wanted to see if there is anything to see. So that is from my previous power up. So we got a resistor here that goes red glowing, but what is much more alarming, that is the main transformer, and that one goes also red glowing. So what you see here is, no, it is not. It is not the transformer. It is to the left of it, where we got those two resistors. Okay. Whew. So it's probably not that bad, but 300 watts, really? I don't know. I'm not super happy about it. I'm super sad and sorry about this. I've been investigating around here with my thermal camera, and those two resistors, they are ice cold. It was because my angle here was not right. So now I rotated the unit so I can really see what I'm doing. And I must say, this looks like we have something is bad in the transformer. But it's most likely not even that, because if you look at the wires that comes out of the transformer, those wires, they light up as well on the thermal. And I can also see it in the wires that goes all the way here. So, I mean, something is shorted So what I want to do is I want to pull out all the tubes and see if there's a shorted filament in one of the tubes. And then I will of course mark everything so I can put it back in, because I think this is a 6 point something voltage, and then that could explain that as a filament voltage, right? So I'm ready to start again. I think I found the problem. It was this nasty short. Somebody had the idea to put it between these two, remember? I couldn't see this from the behind and I couldn't read that this was of course a filament output that goes to the front. So with this one shorted, obviously, the whole unit's gonna use a lot of power. So now I've dimmed the light again, and let's continue from where we left. So now I can of course crank up the volts, and we're not going to see a lot of power. So this is perfectly fine. Let's just go all the way to 220. Like that. And I see the tubes, they light up really, really nice. And that will be my 28 volts. Why am I only having 28 volts? That is definitely not good. So my output here is not working. This output here is 41. It is responding. So far so good. We got one power supply that is working, and this one just goes down, 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 and then it goes negative. I think we should definitely turn it off and then figure out what is the problem. So here is what I have found so far. Obviously I don't have the correct schematic, but I got a schematic of another similar version, and this is the Oltronix LS15B. And if we look a little bit on the schematic here, I want you to note the 3 EL34s and then the regulator tubes down here. So that's just cathode followers, so they're just in parallel, and they are controlled. Their grids, they're controlled using 240 ohms resistors, and then the signal goes to an anode of a regulator tube, and here we got a 10 mega ohm pull up to a very high voltage, and all this is exactly the same in this unit. So we will get we will have the 200 and okay, here it's 270 ohms. See, one grid goes to the other, and then the regulator or the driver tube, right? And the 10 mega ohm resistor was at this point down here to a very high voltage. And what I did is, of course, I removed the driver tube because that one pulls down that signal, and then I would expect to have full voltage output, and that didn't happen. I didn't get any difference. So I thought, oh, maybe this signal here is shorted by any of the tubes. So I took out one by one and mixed them a little bit, only one tube in, still no output at all. So what I think is that this resistor here is probably broken, and here it is. This is the 10 mega ohm resistor, and the funny thing is it is measuring 15 mega ohm, but I think it's just not working really. And the fun thing is we got more of these resistors, and they're all between 15 and 20 mega ohms. See, there's another one right here, and they just don't work. And this is also in the drive and regulation system. See, we got two of these in the schematic. We got two of those 10 mega ohm resistors, and those three tubes here, that I think is exactly the same circuit. Yeah, exactly. It's not exactly the same, but it's somewhat similar, because we got a voltage regulator tube here, and I think those two or three tubes here, they are more or less the same circuit. At least those resistors need to be 10 mega ohm if it's written on them, right? and that I can see the signals go this way. So that is my first little, I want to try and see if I can get some voltage out. I just don't give up on this unit. If we look, we should maybe look a little bit at the schematic again. So the top part of the EL34s, we see those resistors, and they go into a positive voltage. This is again not the correct schematic, but it shows the idea. So there's a positive voltage. This is sort of an enable voltage for the cathode follower here, right? So this voltage enables the tube, and this voltage is missing on the tube as well. And it is due to a missing ground connection on this system. So I got the voltage on this capacitor, and I found that capacitor, and I'm now following this wire from that capacitor to figure out why is this not connected to the positive output, and this way lifting up the drive enable voltage. So here's how that works. So that voltage here is connected to this capacitor, and there's a rectifier, a bridge rectifier here that makes about 180 volts on that capacitor. And the negative side of that capacitor, see, I had to unwrap the wires here to figure out where is what going, because they're using the same colors. As you can see here, it's also a little bit difficult. And that red wire goes to that hole here, and then it comes up here, and then it goes to this circuit board with a little tube in it, remember? And the fun thing is, this little board is called variable fuse. So this is of course the variable current set point, and the idea is when the output current reaches the set point, then the relay will flip, disconnecting the drive voltage, and then everybody is happy. However, the relay is never energized, and that is what is needed to enable the output. So something here is not working. And the fun thing is about this circuit here, I think this is a thermal resistor, NTC most likely, right? We got the pentode, the UF80 pentode, and we got a little germanium transistor, and of course the relay, and just a few resistors and capacitors. So it shouldn't be too complicated to figure out why is this not working. It was quite funny. It was obviously added later, this little upgrade board, and it's just mounted with one single screw through the center of the tube. Look at that. I mean, this is a completely different mechanically. I mean, the implementation is just so different. Obviously, this is some sort of an upgrade that was done later. So that is funny. But now it's completely opened, so I can show you the rear side of the front. So those capacitors we got here, they are actually in series, and that is the output. We got the output enable for the 500 volts, and also the little potentiometer voltage. That will be the output potentiometer. And then we have the other output enable for that supply that is sort of working. That is a little bit in the low. It only goes from 0 to 75 instead of 150. But I think that has something to do with the resistors that is not correct. And we got a few of these 10 mega ohm resistors, and they are just way too high. And they're using the same kind of quality or lack of quality resistors, but that is what you had back in 1960. I don't know really if I would like to call this progress. So this is the OC76 PNP transistor. The funny thing is my tester here says it's a PNP, but it gets collector and emitter wrong. I mean, the colored dot is collector, and as you can see here, it's wrong. But then, of course, a gain is also very, very low. So this tells me that this tester is just completely confused about this transistor. So what I did is I looked in my little germanium collection and found another little OC germanium PNP transistor, and I put it in here. And I think it is correctly connected. So hopefully that will pull the relay at low currents, and hopefully it will enable my output. We will see about that. Wish me the best of luck. I don't hear any click, so it is not solved at all. Damn it. As you see here, we don't have any kind of control, so this relay is still not pulled, so that means we still have no control. So yeah, I don't know what to do. I don't really have the schematic of this. Oh, maybe we should turn it off. What was he? There is light in the lamp, but then I need to go and measure here and do a lot of stuff. Oh, that is not funny. So while I was starting to test and measure around on the little unit there, I figured out that it suddenly just worked. And meanwhile, I also received all the schematics and the manual. And it turns out there is a 90-second delay in there's a thermal sensor delay, and that has also something to do with the current and all that kind of stuff. So after a little while, when you power this up, you will hear the click of the relay. Of course, now that is possible when the transistor is working, and previous my transistor did not work. So I realized we have another problem, and that is this relay is obviously a 12-volt relay, and I only got 10 volts to drive it. So by overvoltaging the input and giving a little mechanical persuasion to the relay, then it activates, and then I have my output. So yeah, we had quite a lot of different failures, and of course a transistor with zero gain in it, obviously all these things together, and as you can see here, we got the output, and we are now in the 0 to 240, and let's see what that can do. It can do 230, and the meter is set for 500, or it's now 250. So even the meter is also working. So let's put it for 200. This is what the meter says, and then we can see over here we got 200. So all that is really nice. What I wanted to try is to add a little load and to see if the amp meter is right, and to see if it drops and all that kind of stuff. So let's try and give it a little bit of oops, did you see what happened? My current limit was set way too low, and now we have the problem with that relay again. Ah, man, I definitely need to go and change that relay. But anyway, that is not going to be a part of this video. It has already been way too long. But maybe I should show you one more thing, and that is the schematics, because I was able to get schematics, and thanks a lot to Klaus, who was able to find it on the Swedish AEF.SE. And the schematics that we found is for the LS14B, not the BS. And the BS is the one with variable current, a variable fuse is what they call it, right? And this is an upgrade, and that is not mentioned in the schematics. The schematics, they are a little bit difficult to read. I tried to clean them up a little bit, and I will put them in the end of this video, so you can see the different parts of the schematics, and hopefully that will explain a little bit on, about how this thing here worked. It is maybe also fair to mention this one is the lower current version. The other one that I already showed a video about is much more powerful, and that's also why we have why we had the 5 EL34 tubes. We only got 3 of them in this unit, and that is why the current limit is 200 milliamps when it is fully clockwise. And we can of course try that. So now that is 200 volts. Let me show you. So what you want to look at is over here, right? So let me crank up the current. And voltage is completely stable, so that is 100. And then at about 200, you should expect this click. Click, and then it goes off. And now it takes 90 seconds. Fantastic. Don't you just love it? Anyway, I think that is all I wanted to show you. So that is 500 volts, and if we crank it all the way up, it's 512. Maybe we should try and load it a little bit here with 500, just to show you. We can do a little bit of funny stuff here. So that's 50 watts of output, and of course the voltage is completely stable. Let's see if the amp meter is, so that is 100 milliamps. That's also super accurate. Wow, what a fantastic unit. And all we need to do is change this relay, and then everything is super duper nice and good. Oh, very useful product, really. Anyway, thank you very much for watching. Bye bye.